Alright, so let's continue HackerRank. Now, in specific, what I am trying to purposefully target and pay attention to while I'm doing HackerRank is number one, trying to understand, okay, well, they ask questions in a very different way. How do I gain reading comprehension to be able to understand what they're asking? That's number one. Number two is, all right, well, they ask a question. How do I map which algorithm to put onto the HackerRank question? Okay, that's number two. Number three is going to be now getting practice actually writing out the algorithm and completing the problem. And then, yeah, so that's kind of what I'm trying, the main points of what I'm trying to figure out. And then, obviously, if I encounter an algorithm or something that I'm not sure about, well, why did I not know about this? And how do I make sure that I fix that and understand it? So, all right, solved this one. Now let's do find the smallest missing positive number. So this is also an easy. So let's just start going down these. So solve question or solve challenge. Okay. So find the, and by the way, there's that. Okay, here we go. Find the smallest missing positive integer. Okay. So we are looking for a positive integer and we want to find the smallest one which doesn't exist. Okay. Given an unsorted array of integers, find the smallest positive integer not present in the array in O of n time and O of 1 extra space. Okay. So, yeah, as it says, unsorted, and we're not allowed to sort because that's log or in log n. So we can't sort it. Why would I not be able to do two for loops though? Because that would be one pass and then doing another pass, that would be log of n, right? So I would come here, ding, 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 try to find the lowest positive, but lowest missing. Given an unsorted array of integers, find the smallest positive integer not present. Okay, that's so obviously with the O of n, we're not looking at any of the dynamic programming or backtracking or any of these kinds of questions. We are going to be looking at like some type of not trick question, but just would two pointers or sliding window or any of this help? This explanation. We want the smallest positive missing integer. Swap with index 2. Okay. Is out of our range, move on. Here, swap with index 3, so 1 and 3, okay. swap with index 0 equals 1. Now move 1 at index 0 and 3. Index 1 has -1, not 2. So maybe this is some sort. Is there some sort of like scanning algorithm that I'm not aware of? Because what I've mainly been doing is following like Nicode's map, and so if one of his algorithms isn't captured in this question, maybe I am just unaware of it. So I'm thinking something with 2 pointers, and the way that we're swapping 2 elements also makes me think that this has some connection to 2 pointers. But now, how do you actually identify which? So I have a pointer at 0, okay, and then I seem to be moving that pointer over by 1, okay? But if I'm here, swap with index 2, and how do I know index 2 without searching through the entire array? I can't scan the entire array. And I have to do O of n or O of 1 space, so I'm not able to store this in some kind of dictionary or anything. And then, so then we still have 1 pointer at 0, and then the value -1 is out of range, so move on. But it wasn't, oh, okay, here to here. So I needed to know for some, I needed to know somehow that this was the lowest. And put my pointer there and then swap those two. Okay. But now my pointer is still here. Okay. And now I say -1 is out of the range, so I move on and I move my pointer over by 1. So this has something to do with sliding window, or 2 pointers. So now I'm here. Value 4. Okay, swap the with index 3. 0, 1. So this one, which is the current lowest element in the list, right? Because we moved that -1 over and swapped it with a 3, so there's a 3 here. So I do 1 and 4, so now it's 1, 3, 4, kind of like that. 1, 3, 4 right there. Yeah. And my pointer is still here, but now it's pointing at 1. Okay. Value is 1, yeah. Swap with index 0. Why would I do such a thing? So this just breaks. And there's no, it's just jumping around. So it seems like this second pointer is just a magic one that automatically knows where the lowest number is at all times. But it's not even the lowest number, it's the lowest number within our window. And then it all of a sudden it becomes the lowest number absolute. So it's no longer the lowest number here, it's the lowest number absolute. Okay. So, all right, cool. I don't know. We are going to search it. All right. Uh, can you tell me the concepts involved in this problem and which algorithms I need to study and how you would suggest studying for similar questions to this? Question mark. I read the problem and I'm not understanding it, period. No, I am understanding the problem. And I uh, am not coming up with any ideas on how I can solve this, period. I'm thinking about something to do with two pointers, period. But I don't see how I can use this actual algorithm to accomplish what needs to be done, period. Do you have any suggestions for me? Question mark. All right. This particular interview challenge, often called first missing positive, is famous because it constrains of n, yeah, forces you to be extremely clever. So I don't like clever problems. I just want to do an algorithm problem. What I really hate with leak code, or just coding problems in general, are those like trick questions. They are trick questions. It's just like, oh, okay, well, how would I have even thought of something like that, right? Like, so those are. Was this a trick question? I'm not sure. We'll find out, I guess. Um, forces you to be extremely clever on how you. Okay. Cyclist sort. Okay, or in place hashing. Okay, both of which I have never heard of. Uh, when a problem asks for O of n time and O of 1 space, and the data involves a range of numbers like 1 to n, you should almost always think of cyclic sort. Okay. Once again, I have never heard of cyclic sort. This is actually pretty good information because it's something I was unaware of. As I said, like I followed NeetCode's map and I have those concepts. But if it's not in one of those concepts, I probably haven't touched it yet. Which actually reminds me, I do need to go in and learn more about sorting in general because now I always just use the whatever the dot sort, the method in Python. Okay. When a problem, so there's something called cyclic sort. Awesome. A new tool that we can start utilizing. In this problem, the ideal state. By the way, this is also something which is nice that we're going to a different platform, which is HackerRank, that we're being exposed to different concepts. Exposed to different concepts and increasing our breadth to be able to increase our probability of when we actually see a real problem. I don't think it's possible to get to the point where you have a 100% chance of being able to solve the question. But the point of practicing leak code is to increase your probability of being able to solve it when it really matters, right? So if they give me something which is cyclic sort, all of a sudden now I am in a much better position. Okay. So in this problem, the ideal state for an array of size n is the number 1. Okay. The ideal state for an array of size n is that the number 1 sits at index 0. The number 2 sits at index 2, and so on. Okay. So just trying to get to the point where each of the indexes are aligned, kind of. The goal, put every number x into its rightful home at index equals x minus 1. Yeah, okay. The constraint, since you can't use extra memory like a hash set, you use the input array as its own hash map. The input array is its own hash map, okay. The algorithms and techniques to study. So to solve this, you need to study these specific areas. In place array partitioning. Okay, similar to the logic used in quicksort. Okay, you are moving elements around based on criteria without a temporary list. So the other thing is, as I just said, like I haven't really. Okay, this is definitely kind of like, oh, here's a new avenue that I haven't really looked at, which is all of these different sorting algorithms. I know that there's bubble sort, there's quick sort, there's apparently cyclic sort, but I haven't really looked into those yet. So that's something, okay, fine. There we go. Good thing we did this problem, right? Or attempted to do this problem. I haven't even written a single line of code yet. You are moving elements around based on criteria without using a temporary list. Okay. Arrays as hash map. Learning how to use the index of an array to represent a value. For example, if you see the number 5, you go to index 4 and mark it, either by swapping or making the value negative to check off that 5 exists. Okay, cyclic sort pattern. This is a specific pattern used when the input data is in a defined range. It allows you to sort the number in linear time by swapping them to the correct positions. So why 2 pointers felt right but isn't quite it. Your intuition about 2 pointers was close. 2 pointers are great for searching or partitioning. Okay, so I also need to pay attention. This is one of the other things that I said that I need to pay attention to is trying to map the question onto the algorithm onto the question, because normally when I do leak code or neat code, both of them are the exact, well, they're the same in what I'm about to say. You always know what algorithm to use because you selected the section, right? I am in backtracking, so therefore I am going to use backtracking. I am in binary search, so I every question that I get, my brain already knows this is going to be a binary search problem, or this is going to be a 2-pointer problem because I clicked on the 2-pointer section. Now it's time to try to find or think about what common situations does 2-pointers have, and why was this one not a 2-pointers? Okay, so it's for searching or partitioning, like putting all negatives on one side and positives on another, okay? Okay, that makes sense. I can kind of see how I might do that. You could use 2-pointers as a first step to move all non-positive numbers to one end of the array, but that still doesn't tell you which positive number is missing. Yeah. you need the in-place hashing cyclic sort to actually track the missing values. All right. So if you feel stuck on these type of clever array problems, I suggest using this roadmap. Categorize by constraint. If you see O of n time, O of n space, the answer is usually a hash set or frequency array. So a lot of these, like frequency array, this is new as well. I need to start writing this down. Hold on a second. So I'm going to write down some of these concepts. So I'm going to come back up here. The first one is going to be, and this is just things that I want to study. So I'm going to say cyclic sort. Cyclic sort. Okay. Next one is going to be where in place partitioning. Okay. In place partitioning and used in quicksort. Okay. Arrays as hash map. Arrays as hash map. Okay. And now we have something called hash set or frequency set. So with my understanding of like a hash, I always just think of a dictionary where you have a key value, right? And so it's just the Python dictionary. Or you can have a default dictionary. So I don't know if hash set is different because, okay, well, I know what sets are, and I know what hash just means dictionary to me. So is it a set of dictionaries? But I don't know. If you see O of n time and O of 1 space, the answer usually is cyclic sort. Bit manipulate. If it's a bit manipulation, goodbye, right? See ya. Or two pointers. All right, so search for the cyclic sort pattern online. There are about 5 to 6 common problems. Missing number, find all duplicates. First missing positive that use the exact same logic. Draw it out. Like the explanation in your prompt, physically draw the array on paper. If you have this right here, ask yourself, if I want 1 to be at index 0, how do I get it there without losing 3? This naturally leads to swap logic. Okay. The logic for this problem, iterate through the array here. Okay, while the current number... Okay, so let's read this. I'm going to take a sip of coffee before I read it. Iterate through the array. While the current number, order number I, is a positive integer between 1 and n, and it is not in its current spot, swap it with the number at its target index. Iterate through the array. While the current number, so index that I'm at, is a positive integer, okay, between 1 and n. That's why we moved over when it was negative 1, okay? And it is not in its correct spot, meaning that the index does not equal the order number. This the index is, so if I is 2, right? I go to order number and I get the element at index 2, okay? 2 minus 1. So this evaluates to 1 less than the number which the index is currently at. Oh my gosh, okay. And then I evaluate that here. Okay, that's wonderful. Um, after the loops, after the loop, scan the array from left to right, the first index I, where I is not, or the where the value in the array does not equal that index itself plus 1. That's the correct answer. If all of the numbers are correct, the answer is n plus 1. That kind of makes sense. Okay, so what I think I will do now is I will end the video here. I'm going to go and try to look through a lot of these new concepts that I have come into just now, and I'll try to learn about cyclic sort. I'll try to learn about different sorting algorithms. I'll try to understand all of those 4 things that I have written down here with the hash sets and frequency sets, arrays as hash maps, in-place partitioning, quick sort, cyclic sort, all of those things, and different sorting algorithms as well. So I'm going to go look that up, study that today, and then I feel like it was, even though we didn't write a single line of code, even though I have no idea about this, and it's an easy, oops, I feel like I did encounter some pretty important algorithms that I previously was unaware of, and I'm very happy with the results of the video today because I was able to meet these new characters, and it let me realize the gaps in my knowledge. And also, if you notice when I was reading this, I have it highlighted too. This one right here, this just like, remember when I say sometimes what I'm scared of is what I need to do? And just looking at this, trying to wrap my head around this, it got me, wait, hold on, this. And so obviously there is something that I need more practice with to be able to more quickly identify how you have nested indices, or nested like list within the list of the index, and trying to understand this line of code more. So I need to investigate that as well. So that's kind of the roadmap that I'm going to be going forward in today. Anyways, thank you guys for watching this video. If you liked it, subscribe. I would love to have you along on this journey. My name is Timothy Lee Grant, and I'll see you guys in the next video. Goodbye.